Week 4, first hour, data pre-processing. Why do we need to pre-process data? So first of all, pre-processing data or data pre-processing happens right pre-processing, which means that it is the kind of processing that we do to the data before the actual processing. And the reason for having data or doing data pre-processing is that we usually encounter data in the real world, in the databases, in the social media, to be incomplete, noisy, and inconsistent. Incomplete, it can be for sometimes that some attributes do not have values, some attributes are there, but we do not need them. They're actually extra. They're not beneficial to the analysis. And in some cases, the data is actually an aggregation of other data. For instance, the sum of some data or the average of some data. So it is not detailed data. It's also considered to be noisy, meaning that it contains outliers and it contains errors. And in some cases, actually inconsistent, which means that it is not does not make sense with each other. Generally speaking, if we don't have a high quality data, we cannot have a high quality mining results. And therefore, we cannot base decisions or make decisions based on our mining results. Also, data warehousing, where we store a huge amount of data, requires that we introduce or we save high quality data, not um, dirty data. So data pre-processing actually comes in four forms: in data cleaning, data integration, data transformation, and data reduction. And we are going to discuss each one of them and what are the techniques that we apply in order to achieve data cleaning, data integration, data transformation, and finally data reduction. We start by explaining what data cleaning is. So data cleaning involves the filling of missing data, and we're going to introduce some techniques to do that. We're going to talk about how to deal with noisy data, and we also how to identify and remove outliers, and how to resolve inconsistencies. Data integration, meaning that we will be combining, integrating multiple databases or creating data cubes, just as the one we discussed in the first week when we discussed the data warehouses, or actually when we create files. We will also talk about data transformation, and we will explain normalization and the different types of normalization along with data aggregation. And we're also going to talk about reduction, data reduction, where we obtain a reduced representation of data. And when we talk about reduced reduction, we're talking about the volume, the amount of data that we have. And there are techniques that we apply on data so that we will be reducing its volume. However, it will be producing the same analysis results. First of all, data cleaning. And as I said, data cleaning is one of the forms or the first step actually of data pre-processing. And cleaning tasks, as I mentioned in a minute, involves dealing with missing data, noisy data, and also inconsistent data. Now, how do we handle missing data? We already discussed some of these techniques, but here we're going to talk about more techniques. First technique is to ignore the tuple, which means that if we have an object that contains a missing data, we will simply ignore it. We will remove it. We will not consider it within the analysis. Now, there are problems with this approach, because If we do have many missing data, it means that we will be ignoring many of the objects existing, and this is not helpful. We need as much data as possible in order to do the analysis. Another technique is to fill in the missing value manually. Just give it a value randomly without any calculation or consideration. Just give it a value, and this is considered to be tedious. It's tiring, and it's also not practical if you have huge number of records, and this is often the case that you have huge amount of data, so you cannot go one by one and replace it manually. Also, you can use a global constant like such as unknown or not applicable, or giving it a very odd number. For instance, if you have the grades of students out of 60, a missing grade will be, let's say, minus 100 or 0. Okay, so this way you will know that this is a missing data. Also, you can use the attribute mean. Going back to the same example of student grades, you can produce the mean of the student grades. Okay, so you will get the average of all the student grades, and this will be the missing value. Another way is to get the mean for all samples belonging to the same class. Now, if you actually have classes of students, let's say you have classification of students. Let's say that you have an attribute stating that the student is top student or medium student or lower student. So this is classification. This is labeling of the students. So one way or another way of dealing with missing data is to have the mean of top students. And if you have a top student with missing grade, you will put their mean. And then you will have the mean of middle students. Then if you have a middle student with a missing grade, then you will have it replaced with the mean of the middle students, and so forth. And this way, this approach is actually smarter. It will produce results that are more or closer to the real values. Another or final way is to use probability, the most probable value, to fill in the missing value. And in this way, we actually use an inference-based approaches such as decision trees or Bayesian formula. Other problems that we can see in data and that it requires cleaning, such as duplicate records, incomplete data, and inconsistent data. This is not discussing noisy data right now. Now let's move to noisy data, how to handle noisy data. Noisy data can be handled using three main approaches, or this is what we're studying: the binning method, clustering method, and regression method. We will go into details about binning method. However, clustering and regression, we will touch on them, we will speak about them. However, but we do have a whole chapter about clustering and a whole chapter explaining regression as part of classification. So there is no need to go into details here, but we were going to talk about them as part of how to handle noisy data. Now, binning method, which means that we will be partitioning the data into bins. Now, these bins can be equal in depth or equal in width, and we're going to talk about the difference in a minute. But after we partition the data into bins, we will then be applying smoothing on the bins. So when we talk about the binning method, we have two steps. First, partitioning the data into bins, and we're going to talk about approaches to create bins. And after we partition the data into bins, then we will be smoothing the data, and we have three approaches to smoothing the data. We will in the bins, we will be smoothing the data by means. So smoothing data in bins by means. We will be smoothing data in bins by median, or smoothing the data in bins by boundaries. Okay. Now, binning is considered to be a method of discretization. Okay. And as I said, that we do have approaches to creating bins. The first approach is equal width partitioning. Okay, so we need to specify the width of the bins, how many elements will be in the bin. Okay, and we also have equal width, equal depth. We're going to talk about each. Now, equal width partitioning means that we will be divide the data into n intervals of equal size. So we will have, and we will be deciding that we will be dividing the bins into intervals, and these intervals are equal in size. We will see examples in a minute. But how do we calculate these intervals? If we have A and B to be the lowest and highest values of the attribute, which is the values that we're trying to bin or to divide into bins, then the width of the interval will be B minus A divided by N, which is the number of intervals that we want to create. The equal depth partitioning means that we will be dividing the bins into to contain the same number of values. Now, the equal width means that we will have an interval, and these intervals are equal, but does not guarantee that the number of values within the bins will be the same. However, the equal depth, it means that we will have the same number of values within the bins. This will make it clearer. So here we have data. So this is the data, and it is showing price in dollars. Okay. Now, the first step, we need to verify that the data is sorted. So if you get the data and it's not sorted, you will have to sort them from ascending from small to big. Now we want to partition this data into equal depth bins, and we said that equal depth meaning that they will contain the same number of values. The size that we specify here is 4. So bin 1 will include 4 values, 4, 8, 9, and 15. Okay. Bin 2 will include 4 values, 21, 21, 24, and 25. Bin 3 will include 4 values, 26, 28, 29, and 34. So now we have 3 bins, and we specified the size, the depth here to be 4. So each bin will have 4 elements. Now, this is the first step. We divided our values into bins. Now we want to apply smoothing. So we said that we have smoothing by means or smoothing by median. And then we also have smoothing by boundaries. The mean and median are the same, so that's why we did not, we don't see the median here. But it's the same idea. So what will happen is that for each bin, we will be calculating the mean. So bin 1 is, this should be 4. This is a mistake. So 4 plus 8 plus 9 plus 15 divided by 4. I'm not sure the number is correct, but this should be 4. Okay, correct it in your slides, please. We also have 21 plus 21 plus 24 plus 25 divided by 4, 26 plus 28 plus 29 plus 34 divided by 4. Let's assume that this is correct. So 9, 23, and 29. These are correct, but this might be, you know, maybe because of the thing, maybe it's not correct. Anyways, so we calculate the mean for each one of them, and we will be replacing each one of them by the mean value. So bin 1 will all include 9, bin 3 will all include 23, and bin 2 will be 23, and bin 3 will be 29. Now, when we talk about smoothing by boundaries, we actually going to select either the minimum or the maximum value. So we go to the bin and we identify what's the minimum and what's the maximum. So here is the minimum 4 and here is the maximum 15. Let's say that we will choose the minimum. So we will be replacing all the values except for the maximum by the minimum value. So it will be 4, 4, 4, and 15. Here it will also be the same. We will be replacing if you select here, you will be selecting the max. You will be leaving the minimum as it is, and you will be replacing everything else to be the max. So in this case, it will be 25. So it will be 21, 21, 25, 25. Here you are replacing the minimum. So it's going to be 26, 26, 26, and 34 will remain the same because it's the maximum value. Here is the median. In this case, we want to partition this data into 5. It's also equidepth, which means that we want to have 5 values per bin, 5 values. So you will be calculating the median for each bin and replacing all the values by the median. Now, cluster analysis is also used, as I said, to identify outliers. We will identify clusters of data, and we will identify data that do not belong to these clusters. In this case, this is considered to be outliers or noisy data. And as I said, we'll talk about cluster analysis in later chapters. So the idea is that we will be partitioning the data into clusters, and one of the clusters will contain information about based on what did we apply this clustering. And clustering techniques can be very effective if the data is actually divided into clusters. However, if the data is smeared, you cannot group it. In that case, it does not work. Cluster analysis does not work in resolving noisy data. We can also have hierarchical clustering, which means that we will have clusters within clusters, and in this case we can have an index or tree-like structures to store data about clusters. Also, regression can be used in identifying outliers and noisy data, and in this case you will see that the data is following a regression, if you remember the scattered plot when we spoke about it, this is considered an outlier compared to the rest of data. And regression is also used for classification and for identifying our outliers. So I'll stop here, as this is the end of the first hour, and the second hour we will continue from this point forward.